Calculating residuals and coefficient of determination. Residual tells us how far off is our prediction, the difference between the actual value and the predicted value, or the difference between the observed value and the predicted value. That's what residual is. So y is the observed value, y hat is the predicted value, or y is the actual value and y hat is the predicted value. So actual and observed value is the same thing, and predicted value is the y hat we predicted based on the linear regression line. Coefficient of determination r square, it's always written as percentage in terms of percentage. This is the square of linear correlation coefficient r, and this explains the percentage of variation in y explained by least square regression line. What percentage of variation in y is explained by the least square regression line y equals mx plus b? Here's an example. Compute the correlation coefficient between the midterm score and the final score of 10 Stat 1 students. So we're given the scores of 10 Stat 1 students, the midterm scores are given, the final grades are given, and we want to find the correlation coefficient between the midterm grade and the final. I want to see if there is a correlation between them. We know the correlation coefficient from the previous videos. We know that it stays between -1 and 1. It can equal +1, can equal -1. If we have perfect positive correlation, r will be equal to 1. Perfect negative correlation, r will be equal to -1. And r only measures the linear correlation. It doesn't measure any other kind of curvilinear or any other kind of correlation. R can equal 0. R equals 0 means there's no linear correlation between the two variables we're observing. So let's go ahead and calculate R for this given columns, the grades, midterm grades, and the final grades. So I went ahead and created a column of x squared, y squared, and xy column, and I found the sum of all the columns. To save some time, the formula for the R is here, and I plugged in all the values and calculate R, which is 0.8928. We can see there is strong positive correlation, so it's almost 0.9, which is strong positive correlation between the midterm grade and the final grade of these students. Next, calculate the least square regression line. Least square regression line can be calculated using the equation y hat equals b naught plus b1x, where b naught can be found using this formula. We calculated least square regression line in the previous video as well. B1 can be found using this formula. Notice that summation x squared and summation x squared is not the same thing. So predicted value y hat, least square regression line, y hat turns out to be 0.5565x plus 35.39. So when we plug the values in b naught and b1, and this is what our least square regression line, also called the line of best fit, turns out to be. Interpret the slope of least square regression line. So what does this slope mean? Slope here, so if we compare it to y equals mx plus b form, the m is the slope. M is the slope. So the slope is 0.5565. So one thing I noticed is the slope is positive. That means this is going to be a line. If we draw the scatter plot, we're going to have a line that's going rising towards the right side. This slope is change in y over change in x, delta y over delta x, change in y over change in x, 0.5565. This is final grade over the midterm grade. The change in final grade divided by change in midterm grade. So for every 1 point increase, how is it predicted is for every 1 point increase in midterm grade, final grade increases by 0.5565. Let's interpret the y-intercept now. The y-intercept is the b in my predicted, in my least square regression line. So y hat is 0.5565x plus 35.39, and this is the y-intercept. And y-intercept is a score of 0 on the midterm would produce, so if x is 0, what is the y-intercept? The y-intercept is the graph, a point on the graph where the line touches the y-axis. So a score of 0 on midterm means if x is 0, will produce a score of 35.39 on the final. That means if somebody scored 0 on the midterm, they're going to score 35.39 on the final. Interpret the coefficient of determination. Coefficient of determination is r squared, which is the square of linear correlation coefficient. Now we just calculated r on the previous page, which is 0.8928. If we go ahead and square it, 0.8928, r is 0.8928. R squared is, let's see, 0.8928 squared is 0.797091. So it's would be 0.79. If we change it to, it would be 0.80. 0.80 if we round it. So r squared always written in terms of percentage, which is 80%, which means 80% of the variation in the final grade can be explained by this least square regression line that we just calculated. Rest of the variation is due to other factors. So 80% of the variation, 80% of the variation in final grade can be explained by the least square regression line, or the line of best fit. Least square regression line, or the line of best fit. Next, we want to calculate residual for Maria. Residual is the actual value minus, so if you want to calculate the residual, we would be going back to find out what was the predicted value for Maria based on her midterm grade. We can calculate that and we'll know her actual value that was observed. So residual is going to be actual value minus predicted value. The actual value, we know Maria's score was midterm grade was 81 and the final grade was actually 67. So midterm grade is 81. Based on that, we can predict the final grade. That will be our predicted value. So predicted midterm for Maria, predicted midterm for Maria, predicted final grade for Maria, apologize, for predicted final, because that's what the least square regression line does. Based on a midterm grade, it's going to predict a final grade. Final grade for Maria. So that would be y hat equals 0.5565x $35.39. So here we're going to plug in x as 81, and that will give us Maria's predicted final grade, and we can use it to calculate the residual. Again, residual tells us how far off what's the difference between the actual value and our predicted value. So 0.5565 times 81 plus 35.39 turns out to be 80.47. 80.47. So residual for Maria comes out to be y minus y hat, and her actual score on the final was, let's check, was 67. So 67 minus, we can have a negative residual here because 80.47. 67 minus 80.47, that's negative 13.47. Residual plot is a graph demonstrating how the observed values differ from the line of best fit. So what is the difference between the observed value and the predicted value? That's gonna be demonstrated using a residual plot, and we'll see that in the next video.